This is the lecture for section 5A, the fundamentals of statistics. This section is going to cover a lot of different definitions, so please bear with me as we go through them. Statistics is the science of collecting, organizing, and interpreting data, and statistics that are data that describe or summarize something. Anytime we work with statistics, we can work with a population and then a sample. Well, the population in a statistical study is the complete set of people or things being studied. The sample is the subset of the population from which you are going to communicate with and gather data from. Population parameters are specific numbers describing the characteristics of the population. So if you have access to the entire population and you find maybe an average value, you would have a population parameter. However, if you only work with a sample or a portion of the population, the numbers that you get to describe those values are called statistics. We're going to look at an example and describe and discuss the population, the sample, what the population parameter is, and then the sample statistic would be. Our situation is agricultural inspectors for Jefferson County measure the levels of residue from 3 common pesticides on 25 ears of corn from each of the 104 corn producing farms in the county. So we want to first talk about the population. Well, the population is going to be all corn that is in Jefferson County. The sample that we have taken is the 25 ears of corn. Now, when we want to discuss our numbers that we're going to get, our population parameters are going to be values that talk about the residue that it would be on all corn had we had access to all the corn. Where the sample statistic is going to be the numbers that describe how many pesticides are just on those 25 ears of corn. So you need to be able to separate what is the sample, that small group you're looking at, versus the population, which is going to be if I had access to every single one in this group. What is that group? Another example, we have in order to gauge public opinion on the president's plan to contain Iran's nuclear program, the Pew Research Center surveyed 1,001 Americans by telephone. So what's the population? Well, it's easy to see the sample. The sample is easy because it's right here. I have 1,001 Americans. So there's my sample. Well, I've taken a sample of Americans, meaning that my entire population would be all Americans. And then that means we can have a population parameter as well as a sample statistic. And they're both going to tell me the same thing, which is how many agree or their opinions on this plan, but it's in relation to either the population or the sample. So the population parameter would be the opinion of all Americans for this plan, where the sample statistic, the value we're going to get, is just the opinion of the 1,001 Americans on the plan or for the plan. So they're both talking about the opinion of the Americans for this plan, but it's just a matter of, is it all of the Americans for the population or just the ones that we've sampled for our sample statistic? The following lists the steps for a statistical study. You're going to kind of come up with a question or a goal for what you are going to study. You will then determine a sample that is going to be what we talk about random. It's going to be a good representation of our entire population. Then we are going to actually, whether it's ask questions or measure things, we are going to collect data from that sample. We can then create graphs, we can create tables with that information, and we can even go on and infer things. That's to take something from the sample and apply it to where we think, if we had access to the whole population, what that would be. And we can draw our conclusions. So you start here with identifying your goal. And then you're going to think about the population that you're going to work with. Well, most times we don't have access to the entire population, so we are going to draw from the population a sample. From that sample, we are going to gather some information. That information gives us what are called sample statistics. We can then use those sample statistics to estimate what we think the population parameter would be, so that we can then draw conclusions back about our population. Let's go through that entire process with this survey. Each month, the U.S. Labor Department surveys 60,000 households to determine characteristics of the U.S. workforce. One population parameter of interest is the U.S. unemployment rate, defined as the percentage of people who are unemployed among all those who are either employed or actively seeking employment. Describe how the 5 basic steps of the statistical study apply to this research. Step 1. The goal of this research is to learn about employment and or unemployment within our population of all Americans who are employed or actively seeking employment. So what we need to do then is we need to figure out how we are going to create our sample in step 2. The Labor Department always samples 60,000 households of people that are employed or seeking employment. The Labor Department will then ask questions of those 60,000 people that they chose for the sample, and their responses are going to be called our raw data for the research. That's going to give us our sample statistics. We could easily figure out what percent of them are employed or unemployed. Step 4 is going to take that and be able to go back to the population and make estimates about the population. We take that sample value and we use some processes of statistics to make estimates on what we think is going to happen for the entire U.S. population in regards to employment or unemployment. Finally, the Labor Department can draw its conclusions based on what we found from our sample, how we related that to our population, and then they can go and compare. How do these current unemployment rates compare to where we were maybe last year or maybe the year before? Are we doing better or worse? And then they can decide, well, what do we want to do to make this a better situation? Now we come to the point where we talk about how we get that sample in step 2. We mentioned that it has to be a representative sample. That means we want to make sure we are getting all of the different people or objects, whatever it is that we are looking at, we have the same, would say, probability, or we have the same chance of choosing every single type of person that we want to look at. So for example, if I wanted to look at parents of school-aged children, I'm not just going to pick all the moms. I need an equal spread of moms and dads. If I was going to look at all Americans, I'm not just going to pick the white Americans. That would not be representative of the entire American population, because we have Hispanic Americans, Indian Americans, Black Americans. There are so many different groups that we have to make sure that each is represented in accordance with how common they are in the population. So we're going to talk about some ways that we can make sure that this happens. The first option is simple random sampling. This is a good sampling method. Ways you can do this: you can put every single person's name in a hat and randomly select some of them. You can give everybody a number and then use things called a random number generator and use the numbers that it generates. Basically meaning every single person has the exact same chance of being selected, so it is random. That's great. Systematic sampling is also a very good method of sampling. What this means is we're going to pick a starting point and then go every so many people. So maybe we select every 10th person or every 50th person or every 128th person. It's up to you based on how many are in that population, how many we have to work with, and how many I want. This last one on this slide is called convenience sampling. This method is not good. Okay? This does not yield good results. A convenience sample is one where it's just convenient. So you ask all the students in your class. Well, you may not get a representative population if you're just asking the people you have easy contact with. Same thing is it's going to give skewed results or biased results. These are all terms we're going to talk about here. So if you have a very conservative news program and they post on their website a survey, well, they're only targeting conservative viewers. So their sample is not going to be representative of all the population. Their results are going to be related to conservatives. So we want to make sure if you have a good sample, you want a good sample, you have to access everybody, not just the people with the same beliefs as you or the same skin color or the same gender. We want an accurate representation of everybody. These last two sampling methods are good sampling methods. They get a little confusing, so I will do my best to explain it. Eventually, we have some images here on the next slide to hopefully help explain them a little bit better. Cluster sampling, the first thing you're going to do is divide the population into groups or clusters. And then we are going to use randomness to select some of the groups. So maybe I break my population into 10 different groups. And then I use a random sampling method to pick 3 of those groups. What I'm going to do is I'm going to choose all of the members within those 3 groups. So the way I represent this is all from some. And A is very close to C, so I usually try to relate those together. Stratified sampling, you're going to start with that same type of process. You're going to divide the population into groups called strata. So instead of putting them in clusters, we're putting them in strata. But now what we're going to do in this one is if I have 10 groups here, I'm going to pick some from all of the 10 groups. So I have to pick some from the first group and the second and the third all the way through every single one of the groups. So this one is called sum from, F-R-O-M, from all. So stratified picks sum from all. Cluster is all from some. Here's images to represent all 5 sampling methods that we talked about. First one is simple random sampling. Here you can see there's this number list, and using computers really is the best way to do it, to just randomly generate numbers, and then we pick those people. Systematic here, you can see skip, skip, take the third, skip, skip, take the third, skip, skip, take the third. So I'm going to go through that whole process. Convenience here is, hey, I have access to you. You're walking right by my apartment. What do you think about this? Cluster, you can see here, this whole area is broken into 32 different sections. So rather than picking some from all 32, because that's a lot of people, what they did is they picked 3 sections randomly, 5, 16, and 28, and they accessed every single person within those groups. Versus stratified, where here you can see we broke females and males. So we broke them into like categories somehow, just like we broke these people into like categories based on where they live. So you always break them up based on something that makes them similar. This one, though, you end up, I'm going to pick 2 from here and 2 from here. That's what this represents. So however I break it up, I have to sample from every single group, or however I break it up, I can just pick a few and make sure that I access every single person in that group. I'm going to give you examples of every single one of these. You're conducting a survey of students in a dormitory, and you choose your sample by knocking on the door of every 10th room. By choosing every 10th room, you have done a systematic sample. To survey opinions on a possible property tax increase, a research firm randomly draws addresses of 150 homeowners. Keyword there is randomly draws. If you hear that word random, we have simple random sampling. This is that example of the agricultural inspectors in Jefferson County taking the 25 ears of corn from each of the 104 corn producing farms. All right, so I'm taking a sample from all of the corn. So sum from all represents that I have done a stratified sample. Stratified sampling is, again, a good sample. To see how people like a new product, a small beverage company conducts a taste test by offering a taste test to customers at a local grocery store. Well, they are using some convenience here. I'm just going to this specific grocery store, one grocery store, and I'm only accessing the people there. That's not going to be a very good sample. It's just convenient. So I may not get a very good representation of the entire population of all people that are going to buy this beverage. And you can see here at the end, it says, well, maybe if you're in a neighborhood with only a single ethnic group. We know in Chicago that happens all the time. You have Chinatown, and you've got different areas of the city that only have certain ethnicities in them. So if you're only working in one area, you're not going to get a good result for representing all of the people you may want to target. Anthropologists determine the average brain size of early Neanderthals in Europe by studying all skulls found at 3 sites in southern Europe. So they're taking all from some of the sites, which means cluster. And a cluster is a good sampling method. Another aspect of statistics is whether you are doing what is called an observational study or an experiment. In an observational study, all the researchers are doing is observing or measuring or asking questions. There is no form of manipulation, no form of influence on the people. In an experiment, however, what you're going to do is you're going to treat two different groups separately. Maybe you give one a drug and the other the placebo. Maybe you break your school, your third graders, into two different groups, and one group uses book A and the other group uses book B, and you want to see which one has better results. You're actually treating the two groups differently. When working in that experimental arena, we have a treatment and a control group. The treatment group is going to be the ones that are getting that treatment. So they get the drug, or they get the new book that you want to try instead of the old book, book A. The control group is going to be the group that's held as normal. So they would be the people that don't get the drug, they get a placebo. Or they would be the group that was still using the same textbook that we've been using before. It is important to make sure that the people in each of those groups are good samples, that they're relatively similar. You have the same amount of males and females, same amount of genders. You want them to be alike, except for the fact that the treatment in one is different than the treatment in the other. So what do we have? An observation or an experiment. You guys try these and give me your comment as to which one you think is the observation and which one is the experiment. Now on to placebos. When an experiment involves people, bias can arise just because people know they're a part of this trial. A placebo does not have the active ingredients of the treatment that you are testing. So the thing is, if you are in a trial, you may not know whether you are getting the drug or you are getting a placebo. But sometimes you feel that because you are a part of this treatment, you may think, oh, you know what, I've got dry mouth, or oh, I have this symptom. I haven't had that before. So I'm a part of this trial. I must be getting the drug, and that means I'm gonna have this, and this. That's called the placebo effect. So a patient can improve solely because they think they are getting a treatment. And it actually is very well documented that up to 75% of participants who get a placebo can improve just because they believe they are getting a drug and they believe they are getting better. So this is a really interesting concept, which if you look into it, has to be really looked at when you're working with drug trials. Because is the person getting better because of the drug, or is it just because of a mental shift that's happened where they think they have a drug, so they think they're doing better? Ways that they try to limit that placebo effect comes in the form of anonymizing or anonymity. And basically, you're doing your best to keep everyone in the dark as to who got the drug, who didn't. There's two levels in which we can anonymize in an experiment. The first one is single anonymous. That means your researchers know who got what, or the doctors know who is getting what, but the actual participants don't know which group they're in. In a double anonymous, sometimes called double blind test, the person giving out the drug to the test subject, as well as the test subject, do not know which one they are getting. So they try to do this whole double blind or double anonymous to really make sure that it limits that placebo effect, or there is no swaying of the participants so that we don't sway the results. Now, not all experiments are performed well. Sometimes we're going to read through an experiment or a study and we're going to be like, hey, that's a red flag. That doesn't look right. So let's look at this one. A chiropractor performs adjustments on 25 patients with back pain. Afterwards, 18 of the patients say they feel better. So he concludes that this adjustment is an effective treatment. So, what's wrong with this experiment? Well, if you look at what it said, he performs adjustments on 25 patients with back pain. He only has one group of people. That is the treatment group. There is no control group. So there's no comparison between patients with back pain and patients without back pain. So we don't know why they are feeling better. Is it because they think that this is going to improve them? We could have done here, the chiropractor might have improved his study by hiring an actor to do a fake adjustment, one that feels like manipulation, but doesn't actually chiropractically change the body. Or you could have truly made it two groups of a treatment and a placebo. So if you don't have both sides, you cannot claim that this was an effective treatment. What's wrong with this experiment? A new drug for a type of attention deficit disorder is supposed to make the affected child less disruptive. Randomly selected children suffering from the disorder are divided into treatment and control groups. Those in the control group receive a placebo that looks just like the real drug. That makes this experiment single anonymous. Experimenters interview the children one-on-one to decide whether they became more polite. So what's wrong with this? Well, anytime you do a single anonymous or single blind study, there can be some swaying that occurs because the experimenters know which child got the drug and didn't. They may speak differently to those students, or they may interpret a behavior differently because, oh, I know that kid got the drug, so yep, that makes sense. Or, oh, I know that one didn't, so that makes sense over here. Anytime you are working with a drug, the best practice is double blind, double anonymous, so that those interviewing and those getting the drugs both don't know, so you get accurate recording of your results. Up until now, we've talked about all the experimental procedures. So now what if we look at observational? Well, when we work with observational, we have a few different options here. Our book's only going to cover this one here, retrospective or case controlled. And what that does is it uses data from the past. So maybe you look at old medical records or old interviews. And what you're going to do is you're going to gather data from the past. There are other ones called cross-sectional observational, and that's just accessing people right now. So maybe I do a taste test and I want to know right now what's happening. And the other one is called a cohort, which is where you work with people through some process, just kind of observe them over a period of time into the future. We're really only going to see retrospective here, but do know that observational studies come in more than one form. So now when we're asked what type of study, is it an experiment or an observation, we can get a little more exact with what we're looking at. If we want to find the average income of stockbrokers, well, That's just observational. All I'm going to do is I'm going to look at the information at a specific point in time, and there you go. Let's say we want to ask, do seatbelts save lives? Well, first off, we cannot perform an experiment. I cannot purposely put people in cars with and without seatbelts and crash them. That is unethical. So, what we would do is we would look back at observational data from the past, and we would see from the past accidents, past insurance claims, and all those kinds of things, death records, that those not wearing a seatbelt were more injured or passed away more than if they were wearing a seatbelt. So again, this is a observational study. We would go back in time, so it would be an observational retrospective study. So we're a little more specific than just saying observation. Can lifting weights improve a runner's time in a 10K? Well, this we could very easily do an experiment, and we could divide our runners into two groups. One group could follow a specific weightlifting program, and the other group is told you can't use any weights. We would want to make sure that the rest of their running training is similar. The only difference would be their weightlifting. And then what we could do at the end is compare their results. In this case, there is no anonymity. We're going to know who's in each group. The participants are going to know who's in each group, but we could still get some decent results. Can a new herbal remedy reduce the severity of colds? Well, if we want to test some form of treatment, we want to do an experiment, and the best possible way to do that is double blind or double anonymous. So we want to make sure those getting the pills, as though as those handing them out, do not know which group they are going to be in, so we can get the best results possible. After we've gathered all that data from whether it's an observational study, an experiment, and we've compiled it together, we then go on to that inferential step, and we want to describe what we think is going to happen in the population. So the way that we do that is we take our sample information, and we can use what's called a confidence interval, and we can expand it on to the population. So what we do is we judge based on an error that we want to be between. And we, instead of just saying, well, if my sample is 52%, then my population has to be exactly 52%, we create a range of values where, as long as our sample is a good representation, our population should fall within that range of values. So what we can do is we can create a confidence interval, and we're going to use our sample statistic that we found. We can subtract our margin of error and add our margin of error, and that's going to give us a good frame of reference for where we think the population would fall. So a quick example here. If I know, let's say I took a sample and I had 13% were left-handed, I could then, using this inferential statistic, say I have a margin of error of 3%. I could say then the population of left-handed should be between 3 below that, so 13 minus 3, 10%, up to add 3%, 16%. So what I'm doing is I'm taking a single value of a statistic, and I can expand it to the population, but what we do is we create that range just to give a little bit of leeway, because there's no way to be exact. An election eve poll finds that 52% of surveyed voters plan to vote for Smith, and she needs a majority or more than 50% to win without a runoff. The margin of error for the poll is 3 percentage points. Should we assume that Smith will win? Well, if this is our sample, 52%, we need to add that 3% and subtract that 3%. So you can see here, 52 minus 3 gives me 49. 52 plus 3 is 55. So we're expecting the population to be anywhere between 49 and 55%. But we need her to be more than 50. So right now, with these results, no, we cannot be confident that she's going to win, because right now that range is a little below, and it leaves it up to what is actually going to happen.